Insane HSR engineering, how China high-speed rail pick up passengers without stopping, future HSR. This is how the slowest train, the Metupalayam Ooty Nilgiri at India, that runs as slow as 6 miles per hour does it. At that speed, you can almost run alongside and catch up at any time and jump off and back on whenever you want. But it's possible that we can do something similar for high-speed rail. This would mean a much shorter overall commute time, and without the constant stop and go, that may cut down significantly on fuel costs for train operators, which maybe would translate to lower fares for all. Let's find out. The train that never stops. Imagine a high-speed trains run continuously, picking up passengers without ever having to waste time stopping and starting at individual stations. That's the vision behind the revolutionary concept created by Chinese designer Chen Jinjun. The designer explains that on a journey between Beijing and Guangzhou, there can be up to 30 stops. If each stop takes approximately 5 minutes to drop off and pick up passengers, this adds an extra 2 hours and 30 minutes to the journey. Rather than waiting on a platform and filing through the train's series of narrow doors, passengers wait in a pod above the tracks. As the train passes through the station, the pod locks onto the roof of the train, and the passengers descend down a staircase into the train below. The cabin then moves to the back of the train, where people who want to exit at the next stop ascend into the rooftop pod. As the train approaches the next station, the pod detaches and comes to a stop at the station as the next pod is collected. The concept would also save energy and fuel without having to stop and start each time. Moving platforms. UK designer Paul Priestman, former director of British design group Priestman Good, is the man behind the moving platforms concept, which he believes could potentially revolutionize the rail industry. The idea is to have a citywide network of trams that travel in a loop and connect with high-speed rail service. But instead of passengers having to get off the tram at a rail station and wait for the next HSR service to arrive, the moving tram would dock with a moving train, allowing passengers to cross between tram and train without either vehicle ever stopping. While Priestman admits that it will be some time before his vision could be implemented, he says the time has come to rethink how we travel. This idea is a far future thought, but wouldn't it be brilliant to just reevaluate and just rethink the whole process, he says. Another similar concept is where passengers will board these smaller trams, which will catch up to the rear of the main train, allowing passengers to board between the two without it needing to stop at a station. While above ideas sound great in theory, it does have its flaws. Leaving safety factors aside, the system is restrictive in the sense that some stations are more popular than others. What happens if more people than the designated car can fit want to get off at a particular station? Can you imagine the commotion? Future HSR, driverless high-speed rails. According to a 2019 report by engineering consultant Arup, the global population is expected to reach around 9.5 billion by 2050, 75% of whom will live in cities. To keep these fast-growing cities, regions, and megacities moving, efficient public transport is imperative. Cars, electric, cannot absorb an increase of this magnitude, and rail transport, trains, trams, and metros will have to do most of the heavy lifting to prevent our cities from seizing up. Therefore, automated high-speed rail will have a huge role to play in all of this. China has led the way on driverless railways in recent years, including introducing the world's only high-speed autonomous trains, which run at up to 186 miles per hour, 300 kilometers per hour, between Beijing and the 2022 Winter Olympics venues. Japan is also experimenting with bullet trains that can drive themselves from terminals to depots for servicing, freeing up human drivers to run more revenue-earning trains. Big data and the so-called Internet of Things will allow transport modes to communicate with each other and, with a wider environment, paving the way for more integrated intermodal journeys. Intelligent robots will play a greater role in the inspection of infrastructure, such as tunnels and bridges, and in the efficient maintenance of aging structures.